Hello everyone, I am going to make a presentation on safety requirement specification, and this topic will be on SRS documentation and results. The video is being taken on behalf of instrumentationtools.com and automationcommunity.com. Kindly watch and subscribe to the channel. SRS documentation needs IEC 61511 edition 2 and ISA 84.00.01 require that a safety requirement specification SRS be prepared for each safety instrumented system. Clause 10 describes the requirements for the SRS. Clause 10.3.2 lists the minimum items that shall be addressed in the SRS, and results are saved electronically. So these are the different standards, international standards, that specify the requirement for the SRS documentation. The first thing to know is that SRS is required to be before design starts document. The intent of the committees that wrote IEC 61511 edition 2 and ISA 84 was to ensure that the SIS requirements be laid out before design starts and to define the things required to be addressed during detailed design. It has to be a preliminary document during the stage of engineering so that all the required information shall be entered and all the necessary protection, safety instrumented system details and their testing and their validation requirements, everything will be entered so that it is captured clearly during the project phases. Okay, the SRS is not a detailed design document. The SRS used to guide detailed design of the SIS, safety instrumented system, and then be used to verify that the design actually meets the requirements. It is a supported document. It's not a basic design document for the safety system, protection system and all. It will have its own topology and design principles based on which the sensors, logic solver and the final elements, configurations, the logic solvers, different type of logics or mathematical computations will be mentioned. And SRS is a supporting document used to do the safety instrumented system testing, commissioning, etc. SRS documentation needs any organization that does not require a complete SRS be prepared and approved prior to the start of detailed design isn't in compliance with the IEC, International Electrotechnical Commission, good engineering practices, and thus it is likely to be spending way too much money during the detailed design phase. So organization or company has to commit to do the complete documentation upfront of the project, failing which they may need to do sometimes re-engineering which may require additional resources, or they may have to go for additional instrumentation again which involves more time and money and giving higher cost for the management. If a SRS that conforms to the standards, the subsequent detailed design becomes a lot less expensive and is more effective. So if the SRS developed, once it is meeting to the standards, then the rest of the things will follow and the design and engineering process will go very smoothly. In order that SRS to be effective, there is a lot of learning that needs to happen. It is really a good idea to be able to have a quality SRS example to work from if you are developing your first one. So companies who are going to do the first time has to review and see the earlier completed projects, and they have to take it as a reference to do a new one. Otherwise, whenever we are starting to do with the new exercise, there may be some mistakes, may lead to time delay and more expense. And there are different elements to be taken care during the SRS documentation. SRS helping for hazard prevention. The SRS needs to clearly identify the hazard for which each of its safety instrumented functions is intended to prevent, and the functions that SIFs must perform. They have to clearly identify the SIFs perform, what has to do. Operating modes. The SRS needs to define when the SIFs are required to be available and when they are not. The SRS need to describe how and when a SIF is put into service and how and when it is bypassed or removed from service. These descriptions need to be explicit and define what the detailed design needs to enable. So they have to give a brief idea in the SRS about the bypass requirement, when it has to be put in service, when that can be removed, like that and all. The brief discussions has to be captured. SIF performance. The SRS must define the performance requirements for each safety instrumented function. IEC 61511 edition 2 and ISA 54 are big on making sure that SIF activities upon demand. SIF activates. Make sure that the SIF activates upon demand. So that has to be ensured. Okay. Device functional requirements. The SRS needs to define the performance expectations for field devices such as range, accuracy, response time, shutdown valve stroke time, leakage, certification for use. So these are the different parameters within the safety instrumented system that has to be taken care for the better performance of the instruments and valves. So the range has to be captured properly, accuracy of the instrument has to be taken care, response time, how quick the instrument has to work, that has to be entered, and shutdown valve stroke time. The valves, on-off valves, which are acting as a final control element, may have some stroke time, that operating time, that has to be clearly mentioned. They have to go through some leakage requirements as per the APA standards, that has to be mentioned, and certifications for use. There may be requirement that the instrument and valves need to be certified to work in the safety instrumented system. Further we go on, operation and maintenance requirements. The SRS needs to define the testing and verification requirements for the SIS and its SIFs, safety instrumented system, and its safety instrumented functions over the complete safety instrumented system life cycle. The SRS should define what procedures must exist. So that maybe there are different procedures within an operating plan in a process plant. So the SRS will define what are the procedures required for the operation and maintenance of the plant. One is operating procedures and initial validation procedures, periodic test procedures, bypass procedures, performance data records. There is any system or instrument need to be maintained, and if there is a requirement to do a bypass, that has to be there, and performance data, how the instrument should perform, that has to be evaluated, those records. And periodic evaluation. The SRS does not include these procedures or periodic evaluations, but needs to identify the requirement, the procedures we developed. But the periodic evaluation like proof testing, visual inspection and all not be exclusively mentioned in the SRS form, but they need to give a reference to some SIF, some other documentation which will give the proof testing requirement, visual testing, visual inspection requirement, etc. Okay, these are the different checklists of the safety requirement specification form. So that has to confirm about the hazard prevention and the operating modes, the safety instrumented function performance, device functional requirements, safety instrumented system design requirement, operation and design requirement, maintenance requirements. These are the different items we saw in the earlier slides. SRS results. Now the form is developed and the results has to be verified. So there are different checkpoints. SRS review to be taken up at multiple stages as below. And these are the different steps to be checked. After detailed design, check below the completion of specification, completion of P&ID review, review of instrument installation done as per design, review of design meets SRS and business requirements, any common cause failure points to be addressed. These are the 5 items to be verified upon detailed design check. Upon approval of design, review of specification and by instruments and logic solvers, installation of instruments, valves and logic solvers, preparation and review of process, application, test or code, write procedures and other documentation. So once the design is approved, the specification has to be reviewed and the instrument has to be bought as per the specifications. The instruments, valves, logic solver has to be installed as per the design, and process application code needs to be, that means application program needs to be reviewed, and procedures for different operations and maintenance has to be updated. There is some safety instrumented system coach for each plant. They have to do the review as below. They have to ensure that functionality meets the specification and instruments are designed to the specification. All design changes properly documented, like P&ID, low power, as-up study, etc. They are properly updated and documented. Enable or disable instruments. Whenever any instrument need to go for bypass, that has to be disabled. These things to be captured in the procedures which the safety instrument system coach will review. And manipulators such as temperature or pressure compensation. If any instrument need to go through the pressure temperature compensation, that has to be updated. Diagnostic instruments details has to be updated. So these are the different checkpoints the safety instrumented system coach will do a review. So why we have to do a detailed review There are few requirements which necessitates to do the detailed review. Instead of just going as a one pass, it is better to do a review so that any rework can be avoided. It is recommended to do the detailed design reviews to avoid costly and resource consuming reinstallation, repurchasing or repetitive work. If there is any mistake, anything, there could be a delay in project schedule, which may call for a reinstallation, or if it is a wrong specification, which may lead to the different product than what should be installed. So it may call for repurchasing, which is going to take more time, and repetitive work. Again, preparation of the engineering drawings, preparation of the documentation, and preparation of the new logic programs, and testing, everything is going to take time. So these are the things that can be avoided if it is taken in a proper way. Implementation verification tasks are part of the mandatory pre-startup reviews as per the international standard, which ensure that SIF hardware, software and operation procedures prepared clearly. For each of the instrument and equipment, there will be one startup procedure. Again, it depends on the company's standard and policies. So this is an international requirement as per the international standard requirement. So that has to fulfill the safety instrumented function, hardware, software and operation procedures to be prepared clearly. So that has to be made clear to avoid any mistakes, to avoid any rework on the safety instrumented system, installation, testing and maintenance. So the beginning of the engineering phase, so these are the details to be taken care and properly entered into the SRS form, so that all the installations testing will go as per the procedures, which may also eventually reduce the rework. So these are the different points to be taken during the preparation of the safety requirement specification. Thank you.